So at this point, you've already done the analysis on your rocket, and you can see that I've created all my data points here. So now we need to go through the analysis. And we can get through the analysis through all this information here in this table in the right-hand corner. Now this is a little harder to read, so what we're going to do is we're going to click on any data point here in the graph. We're going to right-click. When we right-click, we're going to see something that says Analyze. We're going to click on Analyze. From here, this brings up our data full screen. Now there's a couple things that we can do here. We've got our data right here. Now the X represents the distance. That's one of the things that we're going to be looking for. And we can see I got my distance here. My rocket starts at 0.006 meters and ends up at 1.911 meters. So now what we can do is we can subtract our data. So to figure it out, how far my rocket traveled in this particular case, it will be 1.911 subtract 0.006. So when we work that out, we end up with a value of 1.905. So my rocket in this particular case traveled 1.905 meters. Now you should be able to figure out, using this graph, both your information for distance in the horizontal, as well as your time. I also want you to figure out your velocity in the horizontal. Now how can you do that? Let's take a look back at our data right here. And we know that since we have a distance in the x versus time graph, we know that the slope should be the velocity. So now what we're going to do is a line of best fit. Now if you look down here where my mouse is, it says x is equal to at plus b. This should look similar to the equation you learned in grade 9 math, which is y equals mx plus b. Now in this particular equation, this a here, this represents the slope. And if we follow over to here, we see that a is equal to 2.069. So I know the velocity in the horizontal is 2.069 meters per second. So now we figured out our distance, our time, and our velocity. And I will work on time in a second. But how do we figure out our percent error? This is where these calculations come from. We've got our percent error formula, which is equal to, measure minus accepted over the accepted. Now what I'm going to ask is for the measured value right here. This represents the calculations you did on the competition day. Your accepted value. I want your accepted values to be what you've done here in the computer program, what we've calculated here. So in the particular case of distance being 1.9 and velocity equal to 2.069. You're going to use this formula here to figure out your percent error. And for some of you, yes, you can have a percentage error over 100%.